All right, awesome. Well, good morning, everybody. On behalf of our steering committee and working groups, I'd like to invite you or welcome you to MEP 2040's 7th quarterly forum and our Q3 forum for 2023. We're really excited to have everybody here. And today's focus will be the focus on the carbon balance. We have spent a lot of time deep diving individual carbon scopes, finding ways for reduction on a micro level. And today we want to bring it up to the macro level and look at the holistic ecosystem of carbon emissions. So it'll be a really exciting talk. We put this forum together because we know it's a complex problem and we don't have all the solutions or even all the answers or all the questions yet. So we're hoping for a fun and lively discussion here. So the agenda is we're going to have some intros first, but followed by case studies. We have 3 case studies that are really exciting to from industry professionals, our very own MEP 2040 steering committee and working group members. And then we have another round of panel discussion with industry experts that are in the audience today. Near the end, we'll update you on our working groups and the progress that we've made with them. And then finally, we'll do a closing and also a call for ideas for the next forum topic. So don't jump off until you provide some ideas for the next forum topic at the end of the forum. This is our steering committee. We are part of CLF. But do work sitting off to the side as MEP 2040. And our mission is, as stated on the website, you can always go there for more information, but it is to reduce both embodied carbon and operational carbon and carbon from refrigerants within MEP systems. We operate, or we try to operate in partnership with AIA 2030, SE 2050 to create a holistic carbon emissions reduction plan across our entire design and construction industry. And these are always fun numbers because they keep going up, but we have 73 signatory MEP firms at this point, which is really exciting, and another 40 supporting organizations. If you're here and you are not one of these, if you're not a signatory or supporting organization, please consider joining MEP 2040 as one of these 2. It really helps us get the word out and it really shows support for the mission. And then we are also on LinkedIn, so please go check out our page and follow it. We do post updates from time to time and you'll get updates about the quarterly forum that way too. Okay, so today's topic is focusing on the whole carbon balance. So it's an important topic to discuss, but we honestly don't have all or most of the answers yet. Individually by scope, we have some clarity on how best to reduce individual scope emissions, but holistically, we want to consider how various emissions and scopes interact with each other. So, and there's a lot less clarity on that holistic level. So at MEP 2040, we consider our role to bring these big questions to light and have conversations about them. And that's even if we don't have all the answers. So that's the point of this forum today, is start to deep dive into this topic of holistic carbon and see how we can collectively find a way to start chipping away at the nuance and create a clear path forward. Okay, so we have 3 case studies, and Luke, I'm going to call you as the first presenter, if that's okay. So if you can, I'll stop sharing my screen. If you can come on and share your screen and do your presentation, that would be great.
Sure. This is Luke Leung. I am in a location that is, let's just say, far away, so I won't be able to turn on my camera. But Nicholas, can you bring on the presentation and share screen for me? Thank you.
Yes, could someone allow me to share? I'm not able to share the screen right now.
I think you could do that
Oh.
now.
Thank you. PowerPoint. Can you see the screen?
Yes.
Yep. So the topic we want to talk about today is focus on a whole life carbon study of an office building. Next slide. Nicholas? Oh, okay. So for all intents and purposes, this is the building we are looking at, and we treat it as an office building. Next slide. Now the focus today will be on the module A, B, and C. So as you see the screen here, the red rectangle is kind of the whole life carbon, right? The module D is kind of additional to that. Next slide. So the first thing we did was we tried to look for benchmarking. So this is the benchmarking study you are seeing at the bottom right of the screen. Life cycle 50 years, 769 buildings. Now this is more than office building. This is a whole spectrum of buildings. Next slide. What we are seeing is a combined total mean value of 710 kilograms CO2 per square meter among these 700 plus buildings. 710 for A, B, and C module. As you can see, B5 is not included, but that's the number in this benchmarking study, 710 as the mean. Next slide. In terms of percentage, this is the percentage. Oftentimes we wonder, well, is it A? Is it module A? Is it module B? Is it module C? So what you're seeing, this number is very similar to what the UK people come up with, roughly about 60-some% in the A module, 22% in the B module, and about 15% in the C module. Next slide. But in terms of breakdown, now oftentimes when we look at the A1 to A5, we said, wow, the structural number is really big. We got to focus on that. But look at what happened in this study, which include A, B, and C module. Building surfaces out of this 700 plus building end up is the highest at 27%. Mainly is because of A module, but specifically B4 module of the replacement cycle of the MEP system. Structure 24%, internal 21%. Internal is the partition and etc. Next slide. For the office building in specific, the number is about 500 to 600 kilograms CO2 per square meter for the entire office building in the embodied carbon category. Next slide. How about MEP upfront carbon? Next slide. This study is done by London, is indicating that a conventional office building can be up to A1 to A5, right? Can be up to 950. And of that, 133 kilograms CO2 equivalent per square meter is MEP. So let's use that number as sort of guide us. About 133 is the MEP number, right? Kilogram CO2 per square meter. Next slide. Now that is very different than the study that done by the US team with the CLF. Part of that is the CLF study is A1 to A3, not A1 to A5. And the other thing about the CLF study is it is more about the tenant fit out of a base building, though they include some of the base building elements, but many of the base building elements are not included. So their number on the MEP A1 to A3 is 41 to 75 kilograms CO2 equivalent per square meter. Next slide. So in the CLF study, the plumbing portion, the two included is domestic water piping and sanitary sewer piping, and they come up with about 6 to 7 kilograms CO2 equivalent per meter square. Next slide. In terms of HVAC, their number is about 28 to 60. But as you see, there are certain elements not included. For example, facility hydronic distribution is not included. And also the distribution system supplementary components is not included. Next slide. Electrical is about 5 to 15 5 to 16, but then the branch wiring system not included. And the branch wiring for lighting are not included, among many other things that are also not included. Next slide. And then the fire protection, communication, integrated automation, the BMS, all those stuff are not included. That's why the number is lower than the UK number. Next slide. So when this is our study, so we start building on the really good study put together by CLF and try to add on other components to see where we are. Next slide. So what we find out is now what you see here is the CLF study is on the top, and we add on other components. Plumbing is about 12.6 in our study, rather than about 6.2 to 7.2 because we add on other components. Next slide. HVAC, we have about 75, and the CLF study is on the top right-hand corner. Next slide. Electrical, we have about 27. Next slide. Fire alarm and fire protection. Now, this element here was the element that not included in the original CLF study, but in our study here, the benchmarking, we include those. Next slide. So this is our total for an office building that include the systems above. So it's actually quite close to the UK study. So this is the MEP upfront embodied carbon of A1 to A3, about 123. Next slide. What about refrigerant? Refrigerant A1 to A3, in our case, it will be about 33 kilograms CO2 equivalent per square meter. In the CLF study, they also mentioned if you include refrigerant, 40% leakage will be about 38. So refrigerant is a big piece of this discussion. But since a lot of them will be reclaimed later on in the C stage, so that is an element that we put it as to the side to look at. Next slide. And the refrigerant, this is a typical CO2 GWP of 1. Next slide. That's how big is R32 if you do it by relative area, and that's how big R134A. So just to get you a visual image of how much impact refrigerant can have. Big one. Next slide. And also communication security and control in the CLF study didn't include. If you include them, the access control system and emergency voice messaging system, these two add together is around 15. Next slide. So if you add up all the above, now knowing that refrigerant, a big part of this, will get recycled later, right? So we just want to add on all those to see where we are. If you add on all those elements, A1 to A3 is actually close to 171 kilograms CO2 per square meter in the MEP world. So this is our benchmarking study on an office building. Next slide. And then there's elevator, right? Elevator is about 5 in our findings. So just something for you to think about whether elevator, should it be in MEP, should it be in architecture, right? Next slide. So that's the rough order of magnitude of the MEP upfront carbon in our benchmarking study. So to give you some idea of where things stand. Now moving on is the 7th dimension in EPD. As you know, all the stuff we look at is just the global warming potential. It's just one element. Next slide. In this element here, of course, you include this, whole life carbon thing. Next slide. The second element is ozone depletion. Next slide. So since the year 2000 to about 20 years later, when we figure out the ozone problem, we actually make good progress, almost 20% reduction. So now we just have to monitor it. We are in a good place in this regard. Next slide. In terms of near ground ozone emission, the slide you look at is in the atmosphere above, but the dimension here we're going to talk about is near ground ozone. Next slide. We have to continue to monitor the near ground ozone so that it doesn't hurt our people. Next slide. And the acidification potential of the ocean. Next slide. So the carbon dioxide will dissolve in the air into the ocean. That's something we need to continue to monitor. Next slide. And the other dimension is eutrophication. Next slide. Which is the running of nutrients, mainly nitrogen and phosphate, into our water and go into our ocean. Next slide. Because 40% of the nitrogen in US is come from fertilizer, and it does wash down into the ocean. Next slide. So actually it's the size of Massachusetts to form this ozone into the Gulf of Mexico. That's how big this kind of dead zone in the Gulf of Mexico is, because of all the nutrients got washed down into the Gulf of Mexico. Next slide. Next slide. And this is what you see from the satellite. Next slide. There you go. That is the dead zone. So we have to continue to monitor that. One way to take care of it is farmland like this gotta be regenerative. We gotta specify our bio-based products from regenerative farm. Next slide. It's more like farms like this with cover crops to avoid the nutrient runoff. Next slide. The point of showing you all this is in this building here. Next slide. We actually, on top of doing the GWP, we also start monitoring the other dimension. Next slide. For example, we took care of eutrophication, looking at the reduction of 35% in eutrophication. Next slide. Because as you can see, the green area is the eutrophication running off of the nutrient in the ocean. So when we solve the carbon issue, we cannot ignore the other dimension. Otherwise, we're going to be using bio-based products that create eutrophication around the world, that contaminate our water stream. Next slide. Finally, next slide. Finally, the final dimension is the earth components of abiotic and embodied resources. Next slide. So this dimension can be independent of GWP too. So we have to think about all this dimension as we model our building, obviously embodied carbon, but be careful of all the unintended consequences in the other dimension in EPD because of embodied carbon. So that's our benchmarking study. Thank you.
Thank you. Thank you, Luke. That was great. I did fail to share my slide of our presenters. So I'm going to do that right now before our next one, but I'm going to, Kayleigh and Julie, you're up next. Luke, yeah, there we go. Thanks. Here, let me share our presenters real quick. And then we will move on to the next case study. So we here today have Luke, who just presented. We have Julie, Janiski, and Kayleigh Houde from Buro Happold presenting next, and then Kelsey Wotila will wrap us up with the third case study. And apologies for not sharing that before. So now Julie and Kayleigh, if you don't mind sharing your screen and sharing your case study.
Thanks, Christy. 1 second. Thanks, Christy. While Kayleigh is pulling that up, I have the pleasure of just introducing the work, but would note that there's a team of unbelievable folks at BH who have been putting all of this information together. What we're sharing today is 2 studies that we've done. It's part of a wider effort where we've been trying to dig into more of the details around the MEP components of a whole building, whole life carbon assessment so that we can really understand soup to nuts what's included. Refrigerant continues to be a big focus, as does the question of embodied carbon when it comes to scenarios around all systems. So I think many of us, if not all of us, have been doing in the industry lately is working through different scenarios for partial electrification, full electrification, et cetera, of mechanical systems. And in most cases, air source heat pumps are a really important part of that scenario. And we think that there's a really critical conversation to have around what the embodied carbon footprint is of those scenarios and how all of that starts to play out between the greenhouse gas emissions factors of the grid today, what the aspirations are for those grid factors in 15, 20, 25 years, and what that means in terms of the refrigerants that air source heat pumps use today versus what we hope they'll use in 15, 20, 25 years, and how all of that sort of plays out for the purposes of conversations related to what is really the best scenario today, and how do we set ourselves up for success in the future. And in some locations, it could very well be an all-electric scenario with air source heat pumps. And in some locations, that might not actually be the right scenario. So there's a lot more there to do, and not a ton of answers yet as these studies are starting to come into play. But I would encourage everyone to continue to share as best as you can in the working groups, and please feel free to reach out to any of the speakers from today or anybody on the SteerCo if there are additional pieces of information, questions, or studies that you're starting to look at where you could contribute to the overall body of knowledge here, so that we can all sort of collectively help move the market, which is the mission of MEP 2040. So with that, I will hand it over to Kayleigh, and thanks very much for your attention.
Thanks, Julie. All right, so we'll just be going through 2 studies today. So these are 2 very comprehensive studies, so down to the individual receptacles, sprinklers, fire alarm devices. We studied everything in these buildings because, like Luke reviewed in that study, we wanted to really understand what the MEP embodied carbon was, not just a cursory, we excluded most of this in the building, but we wanted to take a stab at what the MEP embodied carbon was. No, we wanted to know everything. We used BOM open source LCA toolkit. We amalgamated about 55 EPDs to be able to cover the scope here, which, as you might know or had guessed, this was a challenge to try to find EPDs to cover the scope of a whole building, let alone 2 buildings. But we were able to do that. We accounted for replacement rates, which, like Luke said, you're doubling or tripling the MEP numbers from A1 to A3 at that point. We used ASHRAE equipment life expectancy values for those. We also used the refrigerant impact calculator for the buildings that had refrigerant in them. And we also combined whole life carbon study numbers with the other LCA scopes for structures, foundations, and enclosures, along with operational carbon numbers in the second study to understand the context of embodied versus operational. So first, to go over the workflow. So bit of an introduction to what BOM LCA toolkit looks like. First, we have our BIM model. We have thousands of these floating around in the industry. So we pull our objects out. This workflow typically takes place in Grasshopper and Excel. Pull our objects out, so ducts, pipes, air terminals, whatever it is. We also have sets of open source EPDs that we've got. We set up our material templates, so things like what the duct is constructed out of, so the different insulations or the different pipe materials. We then map those together to get our environmental results, then interpret those results, push them back into Revit, and then iterate as you change your insulation materials, change your routing, and then you basically would run this again through different life cycles. So you could do this at any stage of design, but whenever you have that BIM model is whenever you could evaluate. So this is an image or a screenshot of all those different EPDs we've collected, and this is what the material template actually looks like in all the different piping materials we had and what that looks like with the different densities. So jumping into that first case study. So this first one was an academic building. It was about 110,000 square feet, 6 stories. It was a mass timber structural system. So we thought this was a good case study because you assume the structures are going to be really low carbon. So then MEP actually becomes a much bigger target for embodied carbon reductions because structures already did their part in reducing embodied carbon. It also was a central plant-based system. So we actually did a takeoff for all of those refrigerants that would be a part of bringing things like chilled water to the building, because you can't just get a massive discount for bringing the chilled water. So we did do a takeoff for the proportion of chilled water from the central plant as well. So again, this accounted for every modeled element. So everything you see here on the screen was accounted for in the embodied carbon calculation. So looking at the whole building embodied carbon, looking at A1 to A3, this also included refrigerants in their first life cycle. So in the first 15 to 20 years of the equipment, looking at the kg CO2 per meter squared, MEP is the largest contributor because of it being a mass timber structural system. So it's about 200 kg CO2 per meter squared for MEP. But I think that's because of the refrigerants in that first instance. So it's about 47%. Structures coming in at 124, foundations at 38, and enclosures at 65. Now looking at the breakdown of MEP as a whole by scope, mechanical versus electrical versus plumbing, fire protection, fire alarm, and lighting. We didn't include vertical transportation like Luke did. Vertical transportation gets caught somewhere in the middle. So I think that is one of those scopes, just like lighting, that's kind of in limbo, but could be taken into consideration in this scope as well between interiors and MEP, I would say. So you can see that MEP is, or sorry, mechanical is the vast majority of that 200 number at 156, electrical coming in at 18.2, plumbing at 12, fire protection at 8, and then the others in much smaller proportions. And then looking at the individual categories within that, mechanical equipment, so anything larger than, let's say, a VAV box, VAV boxes, chilled beams, air handling units, the boilers, the proportion of chillers that would have been counted as central plant, that came in at about 73 or 36%. Refrigerants were 57 kg CO2 per meter squared, or about 28%. And then pipes coming in at 28, or about 14%, ducts at about 16 or 8%. But again, this is primarily a chilled beam-based system, so less ductwork than a typical building. So that number might be slightly smaller than some other building topologies. Now, looking at the individual subcategories per meter squared, we also had the fun challenge within MEP 2040, especially in the DAR group, of what should we be reporting? And that question has been weighing very heavily on our minds. So looking at this in terms of the kgCO2 per meter squared across all those individual categories, we can see that refrigerants very obviously need to be reported. They're coming in at almost 60 kgCO2 per meter squared for just A1 to A3. So like, yes, we need to be reporting refrigerant emissions. And that's just for the first set of equipment on this building. Air handling units are really high as well. These air handling units in this building weighed over 40,000 pounds each. So, and I spoke with the manufacturer and was like, are you sure? They were sure. So 30 kgCO2 for just 2 rooftop DOAS units. Boilers coming in at 20. So equipment very obviously should be counted. Refrigerants very obviously should be counted. Ductwork's pretty high at about 15. Pipes in just the mechanical scope came in at about 12. With plumbing, you can also see even in fire protection, piping was really high. So I think piping as a whole should be accounted for. Panel boards and ATSs in the electrical scope also was pretty high. So maybe we'd want to account for that. But I think the other numbers, if you look at fixtures, all pretty small across the board. So if we were to account for that, maybe we could discount fixtures. But up to this group to decide. All right, so moving on to case study 2. So this is a more traditional building, concrete-based slab with steel rebar, traditional lab office building, 210,000 square feet, 4-story lab office building. It was a LEED Platinum building, again, with steel reinforced concrete structural system. So for this one, we didn't count the refrigerants as part of A1 to A3, just to try to keep it more pure A1 to A3, apples to apples. So the structures were 542, which is more typical of what you'd see for that like 500 number that everyone bounces around for A1 to A3. So 542 for structures and foundations, 134 for facades, and 132 for MEP. So again, we're more in that ballpark of the numbers that everyone talks about with MEP at 16%. Without refrigerants being counted. So looking at that MEP scope, again, mechanical sitting at about 66% because we didn't count refrigerants in this case, electrical at 6%, plumbing at 19%. So these numbers feel pretty similar to the last study. Looking at this pie chart again, we did include refrigerants here just to have apples to apples with the last study. Refrigerants and mechanical equipment were almost identical to the last study, with refrigerants at 33, mechanical at 37. Pipes were much larger in this case at 23, ducts at only 2% in this case. So again, very similar to the last study that was done. We used 3 different types of refrigerant-based equipment. The chillers had 2 different types of refrigerant because we could get low GWP refrigerant in one type of chiller. So when we were able to, we did on this project. So you can see the GWP of all those different types of equipment. So historically, very few whole life carbon studies have included MEP scope, let alone A through D, so including replacements of MEP equipment, but maybe we should. So looking at the ASHRAE equipment life expectancy chart as kind of the guidepost for when this equipment would be replaced. Now, understandably, things likely would not be replaced. The diffusers at year 27 and the heat pumps at year 15. They probably would happen in tandem. But we just used these numbers kind of verbatim and took the higher number when possible just to be a little bit more realistic. So when considering replacements, you can see that that number for air handling units that was sitting at about 40 skyrocketed to 120. kg CO2 per meter squared. That's enormous. That's almost the entirety of the MEP scope. The refrigerants for just the chillers alone are at about 80 for each individual chiller, and one of them had a next gen refrigerant, or the one that's a quarter at 513A. The pipes, once you would replace them twice for the replacement, we're sitting at about 45 kg CO2 per meter squared. So things really start to stack up with those replacement rates. So now in this building that is a very traditional concrete reinforced with steel rebar, MEP, once you start to consider replacement, has lapped structures at 605 kg CO2 per meter squared, with structures just at 552, because it never gets replaced throughout the life of the building in 60 years. So the MEP embodied carbon, and this is without B6, B7 operational carbon. So not great. Now let's take a quick peek at the operational carbon for this building. Just looking at the EUI total for the building, it was 109 for the building per year, with a mix of 104 for electricity and 5.4 for natural gas. It sat the operational carbon at about 1.5 million kg CO2 per year. Now you can see that that's steady across those years. We didn't account for grid decarbonization. So putting this back into context of that A1 to A3 versus the B through D scope with the operational carbon, it still places the majority of the onus on operational carbon at 77%. So even though the MEP embodied carbon is still egregious and almost half of the embodied carbon of the entire building, with interiors not included, which also has crazy replacement rates, as we know, operational carbon still is king in this case at 77%. But interesting to compare the two nonetheless. So final thoughts on these two studies. MEP is responsible for way more embodied carbon than we initially thought. The available embodied carbon studies don't go into nearly enough detail or depth because all of those little parts do add up to a lot of embodied carbon. Replacement rates should be seriously considered. We can't just look at A1 to A3. And refrigerants are still the primary contributor. They're still the thing that matters the most, and we absolutely need to account for them. That's it for me.
Thank you, Kayleigh and Julie. That was fantastic. We did have one question come in while you were presenting. And Scott, if you want to unmute and ask it, feel free. I can read it out loud. Is the refrigerant impact based on assumed leakage only over the LCA time period? That was the clarifying question.
Yes, so the refrigerant was based on the leakage during each of the individual pieces of equipment. So I think the chiller lifetime, I used ASHRAE data sets for both. So I think it was like a 5% annual leakage over each year for the chiller, and the life for the chiller was like 20 years. So it was 3 replacements of the chillers with 5% leakage every year. And then I think like 1% at end of life was the assumption, but I could double check if I pulled up the screenshots again.
Okay, thanks. And if you have questions during the presentations, please be sure to drop them in the Q&A. We're monitoring both the chat and the Q&A. It'd be easier to just have to answer questions in one spot. So if you have a question, drop it in the Q&A and we'll do our best to answer it. And if we can't answer it, we'll present it to the presenters and the panelists when we get to that part of the presentation. Thank you, Kayleigh and Julie again. Now it is Kelsey's turn to share your screen and give your case study.
All right, thanks guys. I always get this order of operations wrong from PowerPoint to full screen, so bear with me for just a second while I get it to full screen. Is it full screen for y'all now for viewing? Okay.
Yes.
So thanks for having me. I'm gonna fall a little bit more on the beginner side as related to studies compared to Luke. and Kayleigh and Julie's. So I'm presenting some work that I did a lot of the research in, but would like to also credit my colleague Jacob Alter, who's a mechanical engineer based out of New Orleans at Bernhard. And the case study I'm presenting is from a project from an architecture firm I used to work for in New Orleans called Eskew, Dumez, Ripple. So their data and their information, and me presenting it a little bit. So as we introduced, we're here to focus on the carbon balance. And as an architect, what got me into the term carbon was whole building life cycle analysis. On the left-hand side of the screen, traditionally that's focused on structure, interiors, and envelope. And as I started getting into this work, I asked the question, why are we not looking at mechanical systems? That didn't make any sense to me. And I started looking at this specifically at building reuse and building retrofit. So how do we manage this balancing act from the architectural side of things to mechanical within the existing constraints of the building? So just kind of what are those main elements we look at architecturally, structurally, with the design team alongside the mechanical engineer? What are those constraints? And try to look at them through a couple different mechanical systems. The case study will look at just one of these mechanical systems, but just trying to start looking at within existing constraints, what are those things we're working with, around, or might need to adapt as we retrofit a building with new mechanical systems. Similar to structure, what are the elements in the interiors that we're looking at? As an architect, right, I'm always asking engineers, how do I get the biggest floor to floor height? How do I have the most open space? How do I have, how are we working around partitions and compartmentalization? Which of these systems are more adept to working within those, or working around what I want for my space design? And then the third element we all know has a big influence on operational performance, the envelope, thermal performance, airtightness, penetrations in the building. What do we do about those? To improve performance and look at all of these elements, the whole balancing act of carbon together. And we know that these things all come at an embodied cost of carbon. We're familiar with seeing whole building life cycle analysis, looking at structure, interiors, and envelope. But like I said, I was very curious about why we're not looking at mechanical systems and what's that cost. And then I'll also get into the balancing act of that upfront carbon cost versus the energy saved or emitted operationally. So the study that I was able to really first take a look at this at an introductory level, which we all span different amounts of time to be able to dedicate to this study. So hopefully this will give you kind of a guide for dummies of where to start looking if you're trying to measure your MEP systems. So this was an office renovation that, again, Eskew, Dumez, Ripple did the design for. It's an interior, strictly interior renovation. The office is in Baton Rouge, Louisiana. It's about 12,000 square meters or 130,000 square feet. It's an 8-story building. And the project was brought to the firm strictly because of complaints from occupant comfort and wanting to look at how to improve that through mechanical system and upgrades and lighting upgrades. And the project did get LEED certified. So in starting to look at the question of embodied carbon impacts, I started just benchmarking from the Carbon Leadership Forum benchmark study. So a typical new concrete and steel building was landing at around 425 kilograms CO2e per meter squared. I did run a whole building life cycle analysis on the project as built, using the as-built drawings from 1984 as if it were built today on structure, envelope, and interiors. And it landed at about 320 kilograms of CO2 per meter squared. And I just wanted that as a comparison to what we were doing, which was renovation. And that renovation was largely just interior scope. As I mentioned, the main structural elements, the envelope, including the windows, were retained. And largely it was just interior finishes and some structural reinforcement from slab cuts, opening up the space that was the impact of the interior. So here we see pretty much an instant embodied carbon savings by not building new, right? We hear this a lot, especially as we may be going into a little more of a recession. We see a lot more building reuse in the architecture space. So that's a good takeaway. It's what we intuitively like to think. The most sustainable building is the one that's already there. But like I said, great, we have embodied carbon savings by reusing this thing, but this isn't representative of the whole picture of the scope of work. So what do the renovations cost us? In this case, the central plant of the building was retained, and the big switch was really just in the air heating and cooling distribution type. It was a variable air volume system, and it was switched to VRF, and they did the typical office energy savings of lighting upgrades from the outdated upgrades to all LED. And this brought the building EUI from a measured EUI of 93 to 27, upper 20s, low 30s, as they're now getting measured data. So I wanted to compare that scope of work to the interior renovation, and looked at, as Luke pointed out, and as Kayleigh pointed out as well, the scope of work for MEP systems and reporting can be difficult to get the data. And I did this off of actually installed takeoffs from the mechanical system or the mechanical installer on their ducts, their plumbing, minor electrical and lighting and mechanical equipment installed. So it's largely just, these numbers are just on the distribution system. And this landed at about 35 kilograms CO2 per meter squared, which shouldn't be a surprise based on that CLF study and the scope of work included. But in the scope of the whole project, this was about half of our impact that we were putting forth for this particular project. So that's talking a little bit about the cost of embodied carbon of all these elements in the scope of a building reuse project, with minor changes to interiors, structure retained, envelope retained, and the mechanical distribution systems is really a better way to look at what was analyzed there. But like we've said, we're talking about the balancing act here, and wanted to touch on what the operational carbon impact was in terms of savings. So this is looking at the whole project's lifespan from 1984 when it was built up till 2030, which if I had updated this slide for MEP2040, I would add those 10 years, but 2030 is that cutoff where we're really trying to align with IPCC and see major reductions. So from 1984, there was obviously an embodied carbon kind of burp of emissions of that 320. And then looking at the Louisiana grid, operationally, that EUI of 93 translated to about 140 kilograms of CO2 equivalent per meter squared. So we see that red line kind of tracking for how much emissions would be, this building would be responsible for up till 2030. But that's not what we did. Obviously, they did a renovation in 2020. So we reduced that operational carbon significantly, even at that cost of embodied carbon. And I wanted to zoom out a little bit and not just focus on carbon, because as we're saying, even within analysis, to not silo elements or silo just global warming potential as the only thing we're looking at, we also need to think about what these buildings are doing for the occupants. So how did this renovation affect occupant health? And this, again, credit where credit's due, is just baked into how EDR was thinking about the work and looking holistically at a project that came to them really as a scope of MEP upgrades, and they took the architectural advocacy path to make it better for occupant health. So they looked at this thermal comfort complaint and asked the questions about how can daylighting be affected? How can we encourage more healthy occupant habits and create open space? So this was one of their plan diagrams showing the use of the private offices and workstations and their relationship to the windows, which were not replaced, were from the 80s, were single pane. And so obviously occupants close to the windows are experiencing different thermal comfort from occupants away from the windows. So they started to look at how to move this floor plan around and create circulation space around the windows, encouraging occupants to move more and increase that buffer of thermal comfort from leaky feeling windows. The other thing they did was, I mentioned the structural reinforcement for slab cuts. They, on this kind of right-hand diagram with the green floating boxes, they did some slab cuts to connect the spaces vertically for this office and encourage occupants to use stairs to get around. And those cuts also created more daylight within the space and just opened up this old cubicle, kind of typical office building to a more modern feel with more openness, open plan, and again, more daylight and connectivity to the other occupants in the building. So this slide is old. They now have an as-built photo of this rendering, but there's an example of one of those opened up spaces and a construction progress photo of materials upgraded from take your typical cubicle office building. So really improved the space for the occupants. But like we said, this was also, again, back in the lens of embodied carbon and operational carbon emissions. So what they found was what was good for the occupants was good for the planet. This is a zoomed in view of that little corner from the overall lifespan from the 80s. So over 10 years, that reduction of operational carbon becomes a lot more obvious and significant. And we also found a 1-year carbon payback of the embodied carbon emissions to that operational carbon savings by 2030. The other thing here, obviously it was a VAV system. We introduced refrigerant with a VRF. So I wanted to look at what the impacts of refrigerant were going forward, especially as related to that operational carbon savings. So here's that number I've talked about, that MEP system number, 35 kilograms CO2 per meter squared. So on the y-axis, I just called that, and the upfront carbon amount was our baseline amount of how much was emitted. Annually, operational carbon to 2030 got to be about 4 times the upfront carbon. And then I applied a leakage rate for refrigerant with a 5% annual leakage rate. The refrigerant was 410A to see how much that increases the carbon emissions over time. So it went from about 14 times the upfront carbon to 16 times the upfront carbon. As some of you may know, we don't have a great rate on leakage. We don't have measured leakage. Well, we have to report how much refrigerant charge goes into a building. We don't have that feedback loop closed of how much is leaked. If somebody reports the refrigerant charge, it's not necessarily tied to a building. So different services, we have all these problems of trying to understand different people servicing the same building. How much is that building leaking? So these are assumptions. And like Christy said, a lot of these things that we're talking about today are questions we still have and need better data on. So we can see that the refrigerant does make a difference just over 10 years. And obviously this building's going to go further than that. So that was a big takeaway too, that well, embodied carbon of the MEP system itself had a fair amount of impact on the scope of an interior renovation. Operational still does, even with a huge reduction in operational carbon, and refrigerant has a big impact within that scope as well. So the big takeaways for me were exactly what I just said. For renovations, embodied carbon has a small impact compared to the operational carbon impact and operational carbon impact savings. The impact of today's refrigerants is about 20% of operational carbon on an annual level. And we know we're seeing this, we have been seeing better refrigerants, but still a question of how do we get those into buildings and how do we deal with the existing refrigerants and start to get better measured data around that. So kind of ending with a call to action of the data I had was really rough. It was takeoffs from what was actually installed in the building with global warming potential numbers attributed to that based on material, and then assumptions around refrigerant. So that's a huge part of what we're doing at MEP2040 is advocating to get better data sets. And those are two things we need, a lot better data on mechanical distribution and equipment, EPDs, and data on refrigerants. So some general takeaways of being able to measure this at an easy level and largely ending on a call to action to get better data. So that's what I've got for you. Thanks.
Thank you, Kelsey. That was great. So we have some questions. I'd like to invite, I'm going to share my screen again here. Give me a second. I'd like to invite our panelists, who I'll introduce here in a second, to come on camera. And I'd also like to invite our presenters to stay on camera if you can, as we have a few questions related to your presentations that we can wrap into the panel conversation. So now that we've done our case studies, we are moving into the panelist question portion of this, but it's really an open discussion. If you have questions for the panelists, please drop them in the Q&A, and we will be pulling them up to the top as we ask the questions to the panelists. Our panelists today are Erin McDade, Senior Program Director with Architecture 2030, Stacy Smedley, Executive Director at Building Transparency, Kent Peterson, Chair of the ASHRAE Task Force for Building Decarbonization, and Jessica Bristow, Director of Living Building Challenge at ILFI. All of you, please come on camera, and I can't actually tell if you are, so I'm sure you are already. So we want this to be an open discussion. I will probably direct a question to someone and feel free to answer it, or if you think there's someone better to answer it, feel free to direct it. It's just a first pass at who might have a first answer at the question, but we're going to start out here. I'm going to stop sharing my screen so we can see everybody's smiling faces. And so the first question that I'd like to present to the group is, and I think we saw a variety of commentary on this in our presentations and the case studies. Is operational carbon much more important than embodied carbon in MEP? It's kind of a baked question, but let's hear some commentary from the panelists. I'm going to ask Kent first to address this, and then Kent, feel free to pass it around.
Christy, thank you. My opinion is a greenhouse gas is a greenhouse gas. I mean, if we talk about CO2 equivalent, we shouldn't be trying to say that one is more important than the other. They're all important, and we have to understand the big picture, as these case studies have actually shown. When we're trying to reduce greenhouse gas emissions, we really need to understand what is the impact of every component and decision that we make in a project. And I know, these case studies were great at giving us across various disciplines on specific project examples. But what we're finding is it even makes a difference about, like, if I'm doing a retrofit on a project and I'm electrifying an existing system that might have another 20 years life in the existing gas boiler system, we may only use most of the heating system for the first 30% of load most of the time, meaning that we found, in many California projects, 80% of all of our annual greenhouse gas emissions from the space heating systems were occurring at the load being less than 30%. And the rest of it was all, just when we're peaking or spending very little hours peaking. Well, we can spend a whole lot of them. So now that's a whole nother dimension to this. We can spend a whole lot of hours operating, at the small amount and get a lot of greenhouse gas savings with a little bit of embodied carbon up front and still use what we've already invested in the system that's there that has life remaining in it. Or we can go and replace it all and have all these refrigerant emissions and have all this embodied carbon, and we're not going to spend enough operational hours to even get any operational savings on the rest of that investment. And this is kind of what our industry is struggling with right now, is how do we make these pay back as best as possible? Electrician, I think, at least in my world, doesn't pay back most of the time. And we could do other things like energy efficiency and things like that pay back. But when we're doing these retrofits, and we have so much existing building stock that needs to be retrofitted, as we start to hit some of these targets, we're really going to have to come up with some unique ideas to look at it. And the case studies were phenomenal today. From the basic to the very advanced that Luke is doing, even beyond what we're looking at on greenhouse gases.
Great, thank you. Any other panelists want to chime in on that topic, operational versus embodied in MEP systems? That's okay, I have plenty more questions, so we'll move on.
Can I add one thing?
Yes, please.
I think, Kent, your comments are super helpful, and it's, as I mentioned, it's something that we're starting to take a look at in terms of finding a balance of system solutions, right? And some of it's location dependent in terms of grid emissions, and some of it's sort of universal. But I think one of the ways that we're trying to think about it is the area under the curve, right, between now and X. And 2050 these days seems to be a good placeholder for understanding what the area under the curve is that makes sense to consider. At the same time that there's obviously a big opportunity to think about what the emissions are today as an urgent near term. The more we can reduce emissions right now, the better. So there's a couple of different time considerations, right? Like thinking about time as the fourth axis. In all of the work that we're doing, but it's super helpful to keep thinking about, and the more that we've got case studies to be able to start to further these conversations along, the better. So I'll just repeat the plea from previous. If anybody else is starting to look at this and has studies, please do put your hand up and share and join the conversation.
Thanks so much, Julie. Next question, I'm gonna start with Erin, if that's okay. So the question is, how should we be advocating for the importance of fugitive emissions from refrigerants if no one's asking for them to be a part of an LCA?
Yeah, I mean, I think if nothing else, the compelling addition to the data and our understanding of this is going to be incredibly helpful. I think that it's interesting because it's comparable to the fugitive emissions and gas consideration question, which was something that people were just unaware of until recently, really, when people started to understand that is such a significant part of our gas emissions. And we have this kind of conception of electrification as this silver bullet, and it certainly is better in theory and potentially from an emissions perspective than using fossil fuel based emissions. But if we are simply offsetting one type of really harmful emission for another, that is incredibly problematic. And so I think we all know what to do. We've done this before. We've been advocates for operational carbon emissions. We've been advocates for getting EPDs for our products and turning that into, EC3 as an example. And so now, because you all are doing this awesome research and we're getting this data to really back our understanding of this impact, it's time for us to step up again and be advocates, not only for collecting our data and making sure it's robust in our understanding, but what are our solutions going to be here? What are the systems that are going to address this, and what kind of design and construction interventions can we take also to mitigate these emissions?
I absolutely agree. I have a follow-up question for any of the panelists, I think, on the refrigerant topic. because we have identified refrigerants as such a big contributor. What can we do today? And then what do we need to wait to be able to further reduce these emissions tomorrow? We have some information right now, but I think everybody we love data, but we can also act today on certain things. So I'd love somebody's take on how much can we do today and what do we have to wait on to really make a difference, a bigger difference tomorrow. Maybe Stacy or Jessica, if you guys want to pop. Oh, Jessica, okay.
I can jump in on this. I definitely am not an expert in the refrigerant side of things, but coming from ILFI, from a certification and standards point of view, one thing that ILFI has always been a big proponent of is getting the transparency, the data, even if it's just putting labels out there of like, what is coming from your building? What emissions are we facing? And then from there, setting more rigorous targets to, help promote reductions and really understanding what we're dealing with and how to make those changes. So I think something that like ILFI is personally doing now, and that within the advocacy space, is just lots of these case studies, understanding, reporting, getting the data out there in a way that's organized and aligned. And across with Stacy's group and Vince, I see on the call too, we're working on the embodied carbon side, which does relate to these fugitive emissions as well. So I think just the openness, groups like this, talking through it, sharing the data, having it shared in a way that's aligned as well. And then as we learn more, setting those more rigorous targets of how to actually work towards the reductions. On the technical side, that's part of why I'm here too, to learn it from everyone who's more in the weeds on that. But that's what I would say for a first step from our side of things.
Yeah, that's great. That iterative type of process where we learn, we act, we learn, we act. So question for Stacy. We talked a lot about MEP systems, embodied carbon versus operational and refrigerants. I'd like to know, even like widening the net to the whole building, and structure and envelope and everything that we have been doing a lot of work on, and you have in particular. Is it possible right now to take a building and fully optimize it for all the carbon scope? Do we have the tools and the resources to look at everything together and optimize it? Or are we still in this kind of like, okay, we're going to do our best to reduce each one individually, but we don't have a good tool for the way the emission scopes interact?
But that's a big question.
It's a big
I probably have
question.
a couple of answers. I mean, I think there's layers to that, right? So the first layer is operational versus embodied, and other tools that allow us to look at that holistically. And I would say there are Cove tools, the one that comes to mind right now, because they're leveraging our embodied carbon data to at least have it as part of the analysis that can happen in Cove when you're doing operational energy analysis. Sorry, my dog's going to bark, of course, right when I'm supposed to talk. But so that I think there's work to be done there. The part about the embodied carbon whole building life cycle assessment level, there are definitely tools that are there to help optimize that piece of the pie. But again, I'll come back to the data. You need the data to be able to do that. And MEP is a place where there isn't sufficient accurate data. There's directional data, but there's not enough data there to get a whole picture. It's MEP, it's things like furniture and other categories that really need the work on the data side. So in that, I think if we can get to the data, we can push it up into the LCA tools that exist to get more holistic in that accounting. And then I think we do need to advocate for more tools on the operational plus embodied carbon side, because especially with MEP, particularly, and the envelope too, the trade-offs are really important for people to understand when they're trying to make those decisions. And those decisions are early decisions when you're in the design process.
Yeah, thank you for that. Kind of following up on that question to Kent, when you're from an ASHRAE standpoint, from an MEP standpoint, when we're trying to do this trade-off between, let's say, sizing of our mechanical system versus how much insulation are we going to put in this building, both have embodied carbon, both impact operational carbon, then you start to tailspin at the design table. Can you give us an idea of how you think engineers, specifically MEP engineers, can start to advocate and address some of these topics, especially when there isn't exactly equipment available today to address some like low GWP refrigerants and things like that. What's our best advocacy method for MEP equipment right now?
Well, the first thing is that I think we've all realized that the first step in most of this is the most we can do on the energy efficiency side. And there are various insulations available out there. Some of them have lower GWPs than others. But if we can reduce equipment sizes, we're reducing weights, we're reducing embodied carbon, we're reducing refrigerant charges. There is actually equipment coming up that is going to be available, starting next year with low GWP refrigerants. Is because, California and Washington mandated it, and you can't even sell equipment in these states until you get to those low GWP. So now we have a lot of people retooling in order to supply that equipment in these states, which is going to, trickle down to be equipment that's available in other states. There's manufacturers out there right now that are producing heat pumps and heat recovery chillers that use low GWP refrigerants today, not waiting till January 1st. And some of those are in Canada, but I mean, this equipment is available if we look hard enough and find it. I think it's really important, as was stated by some of the other panelists, that we just need to start looking at what these impacts of the refrigerants are and how big it really is on the overall decision, and then say, now that we know the impact is large, what can we do and what are our options to actually reduce these impacts? And that takes analysis, it takes case studies being shared. It's going to take more research on behalf of ASHRAE. Right now, we're working on trying to get an RTAR together to do more research on refrigerant leakage information. Refrigerant leakage data is not it's not simple. I mean, we have low pressure refrigerants, we have high pressure refrigerants. Maybe we can put it in that. And then we have the system volumes and how, we have, equipment that's packaged. And then we have things like VRF systems. Our VRF systems we're finding out are leaking a lot of refrigerant. And some of it has to do with what the means and methods are and what type of test procedures are being used during construction. And are there things that we can do on that front? We learned, many years ago when we saw that the refrigerant emissions from grocery stores were so large. I mean, 20% in most cases. And what we did was we decided that the best way to design grocery stores was to come out with standards that showed that you can use glycol instead of using refrigerant piping going down to those refrigerator and freezer things. We're probably going to learn the same thing when it comes to VRF systems. It was a great thing. It sounded like a great thing when it first came out, but now that we're looking at the impact of refrigerant emissions, many cases the VRF systems leaking more greenhouse gas emissions in most installations than what a boiler would have emitted if it was actually running natural gas. And these are the types of things that we say, okay, that doesn't mean we go back to the boiler, but it means we got to do something about the refrigerant emissions. I mean, now that we know where the greenhouse gas emissions are coming from, we've got to move forward and do this. And I think, we're coming out with a whole life carbon guide. ASHRAE is developing on MEP systems, should be out early next year. And it's going to have good examples of where we can go. I know there, some people have talked about EPDs not being readily available for mechanical systems, especially, and certainly SIBC TM65 is a good stepping stone to get us in the right direction, to get us some of those values. We can get there, but we're going to have to walk before we run, and we got to start really expanding our breadth of what we're doing on the engineering and the architectural side.
Yeah, thanks for that. Yeah, I absolutely agree. Moving over to Erin. The question is, are we missing the big picture for whole building, whole life carbon by not including MEP in interiors, where their replacement rates can sometimes cause them to lap the structural carbon emissions? We'll start with Erin. Everybody's welcome to jump in on this one as you see fit.
Yeah, I think that's a good question, especially considering the mass timber case study that showed that due to the dramatic reduction in structural emissions by using mass timber, which yay, suddenly the MEP emissions are a massive percentage of the of the total emissions. And I think, as others have said, since we're in a tough state right now where we understand that this is a challenge, but we also don't have technology and solutions to just make it make the problem go away, make there not be these massive refrigerant emissions. It's the same
thing that we always have to do, where we have to take all of the factors into consideration. We have to take all of the different emissions from all of the different systems. We have to, you know, draw good timelines in the sand. Sometimes that timeline shouldn't be our whole building life. Sometimes maybe it should be something that's a little closer to our global carbon targets. And then we have to start balancing, and we have to figure out what is the, you know, the best way to get our emissions impact as low as possible. And in some cases, it might not be that using you know, an electrification system, a heat pump system with refrigerants is worse. It might not be worse, sorry, to do that is what I'm trying to say. Even with those emissions, all things considered, it might still be the best option moving forward. And so it's just, you know, again, in the consideration of using concrete or steel or mass timber in the structure, what's going to have the least impact over time, and the consideration of what finishes to use, even with replacement rates, what's going to have the least impact over time, and the consideration of what MEP systems use, what's going to have the least impact over time. We need to make sure we're not siloing our analyses. We need to make sure we're taking all of it into consideration and finding the right ideal balance and tipping points. That's, you know, that's the job of design teams.
Yes, that's great. Does anyone else on the panel have a follow-up to that? No, that's okay. Stacy, and I'm going to go around the horn with this question for the panelists, so you can all think of it in terms of your own organization. But right now, what is building transparency for you specifically, Stacy? What are you all doing right now to support MEP equipment data? Also, I'm going to throw refrigerants data in there if it happens to come up. What's going on right now? What are you doing presently and planning on doing in the future?
Sure. Yeah. So I mean, I think, you know, what BT does and what we do with EC3 and the data typically follows what our users and our partners are saying they need. So MEPs become the thing that everyone's saying that they need. From our large tech company clients that are building a lot of different types of buildings with huge mechanical equipment, to MEP engineers. So we're doing a couple of things. We have all of the MEP categories now in pilot in the tool. We're building them out. We're building out the subcategories. We're building out the filters so that we can actually have a place to provide the data as it comes. We're also working on a generic estimate type of data in the tool that's in staging right now, where we could ingest TM65 compliant results for MEP equipment and have them as placeholders in the tool, so that can start to be part of what is accounted for in EC3 and part of the data that can flow out. It's being funded by one of the large tech companies. And we're also working on an LCA data set that's going to include MEP equipment averages that will be an open data set coming out in Tally and also in EC3 in the next 12 months. McKinstry's given us money too from the foundation side of things to really start to understand how we can integrate into the BIM side of the equation for MEP systems, using their design and engineering department to kind of test what integrations would look like with some of those systems. So there's a main focus. The last thing I'll say is our owners can group. I think I saw Anthony on here from SFO. We have a group of about 20 owners, plus sometimes we have a small, but as we're getting into MEP now, those owners are really wanting to come together and figure out how to start asking and requiring the data from their suppliers in a way that's aligned. So if you're an owner, reach out to me. MEP is our focus probably for the next 3 to 6 months in our owners carbon action group too.
Thank you. Let's go with Jessica next. What's ILFI doing to incorporate all of this into your work?
Sure, yeah. So we have a lot of things on the horizon. Some of it relates to the data that, you know, Stacy's gathering with EC3 and how far we can push our teams to really be looking in depth at what is in the projects, what we're achieving, especially on the embodied carbon side. ILFI has always been pretty strict and stringent on the operational side, 12 months of performance period data to get your certification. So we're tracking things really stringently in that way. And what we're discussing now in-house and working on a current update that will be out early next year, and then a bigger picture, like holistic update that will definitely fully in depth have refrigerant considerations, if not sooner than that, that would then work on applying those performance-based parameters to embodied carbon. Just looking more at like what's truly installed on the site, a bill of materials, what's the contribution from the actual equipment, and also further building out our existing building and renovation typologies and projects to make sure that, as was mentioned earlier, there's just so much building stock to be looking into and updating, and how do we, as a standard and as a certification group, really put some parameters and understanding and data around the give and take of, you know, what do we need to be looking at there for renovations. And MEP and refrigerants are high on our list in that research. We also have a technical advisory group for energy and carbon that's been really great. 20 of some of the top like embodied carbon and energy, operational energy, engineers, architects, and academic groups in the field looking into this. And these are topics that we have slated for this fall to discuss with them, especially around refrigerants. So yeah, we're working on it, and it's definitely on the horizon for us. And as the data, you know, is coming in, it's definitely something that we'll be working in more directly and more explicitly in our standards.
That's great news. Let's see, Kent, do you want to talk about what ASHRAE is doing around this
Well, that could
topic?
be a whole that could be a whole presentation.
No, you have you have 2 minutes.
I mean, currently the task force is finishing up 7 guides total on decarbonization, and we've already published the Building Performance Standards Guide, and we're really excited about, you know, Earth Day next year. We're going to see a vast majority of buildings in the United States start to fall under building performance standards, and we have a grid interactive building for decarbonization guide that's going to be published by the end of this year. We have a building decarbonization retrofit commercial and multifamily buildings, which really does a deep dive into the types of issues you run into trying to decarbonize existing buildings, which is going to be very important when we start looking at building performance standards and owners that are trying to reduce their carbon footprints, and what strategies do you use? How do you look at this? All these guides are looking at things more from a whole life carbon standpoint. We have a heat pump application guide that we're working on with the Department of Energy that we're hoping to have out by the Chicago meeting of ASHRAE, which is going to be late January next year. And we have, as I mentioned before, a whole life carbon guide for building systems, which is going to really cover how we need to do some of this analysis that we have right now with the tools that are available today. Not only if you have the EPDs, but how do you even integrate with the CIBC TM65? We're working with CIBC coming out with the TM65 for North America that's being tailored more towards the North American market. And then we have another guide that's going to be focused more on decarbonizing hospital buildings. Those are the guides, but you know, in addition to that, we're coming out with all the education courses that'll be how to use these guides, how to do these things, and, you know, be able to attend with an instructor to be able to learn with other people in a room. So we realize that the training is extremely important, not just getting the guides out there in the marketplace. And, you know, as many of you probably realize, we've been working heavily with a lot of the ASHRAE standards on getting decarbonization and carbon into greenhouse gases into those standards. And so, you know, things like standard 228 that was referenced on some of the calculations for refrigerant emissions, you know, standards like 90.1 that are used very often in getting carbon into 90.1. 189.1 already has that in our high performance green building standard in it. But even our refrigerant standards, making sure that we're staying up to speed with some of the new refrigerants and how we use those refrigerants. And, you know, it was said very well with the third case study that was given today, and that this is not just about carbon. We have life safety, we have IAQ issues, we have other things that, you know, we build buildings for other purposes. But as we start to even transition to refrigerants, it's not just about greenhouse gas emissions. I mean, when, you know, I think Luke showed up on the slide, he put 134A and then he put R32. Well, you know, R410A is going to R32 for a lot of systems, and R32 has 5 times the toxicity level of R410A. So it's not just a drop-in for reducing refrigerant. I mean, we have to deal with the life safety issues. That's probably our #1 priority as engineers when we're out there designing. And all of this stuff, we just have to be aware and get the information out to everyone so we know what we're doing and we're not making mistakes as we start to go through these transitions, that we do it with a head up and knowing what the issues are that we have to address.
Yeah, thank you. And Erin, for Architecture 2030, how are you addressing the topic of today, particularly MEP and refrigerants?
Well, my colleague Vincent is on too, and so we can see if he has a response to that, because the thing that's interesting is until this topic really floated to the surface in the last few years. We felt that in some senses, the operational emissions issue was solved. And by solved, I don't mean, oh, we have no operational emissions globally, obviously, but we know exactly what we need to do, and we have all the tech that we need to do it with. So compared to embodied carbon, compared to infrastructure emissions, even looking beyond the building, the operational emissions issue just didn't seem as emergent to Architecture 2030 anymore. But I mean, again, looking at these case studies this morning, I've already been aware that this was a problem. It's, you know, of course, it's coming up in all of the conversations that we're all having on the sides too. But this is not an insignificant challenge. And so we're going to be talking about this more at Architecture 2030. Vince, I don't know if you have anything that you wanted to add to that briefly.
Sure. So over the last 9 months, Architecture 2030 and a variety of stakeholders, including ILFI, Building Transparency, USGBC, Carbon Leadership Forum, have been participating in a group that's now been called the ECHO Project, Embodied Carbon Harmonization and Optimization, that might have come up earlier. We're reaching a point in which Architecture 2030 is transitioning from a management and funding source of that project, and Carbon Leadership Forum will be taking it to the next level with the partners. And in that project, there were two things that happened so far over the last 9 months. Stacy might have mentioned one of them, which is the development of a shared schema for reporting softwares, as well as tools that we're hoping to help get harmonized and used, so that we're all using the same words and the same fields throughout this work. And that includes MEP. The second piece is around a framework for embodied carbon reporting, and this original work was funded by the Wholesome Foundation for Sustainable Construction, Blackstone Ranch Institute, and Columbia University, and their focus was real estate and what real estate might need in terms of measuring embodied carbon. And so we had a facilitation organization, Building Green, and Sarah Architects work with our coalition to better understand the inputs into real estate embodied carbon focus. And they looked at what they thought was viable now from data harmonization and understanding within the industry. And on that marker for the current draft, there is no MEP. So I want to be clear about that. That's not included. And because there's too many questions still in the facilitator's opinion from doing the one-on-ones for that group to establish that as a marker. That said, this is just the first phase in a long process. So I think the next piece, it's a really clear from CLF's perspective, from the MEP2040 folks, that this is a sleeping giant of an issue, and that if it is not incorporated, we are doing ourselves a disservice. And so I think this will be the next hot topic, not just this, but probably biogenic materials. It's probably another one that's really of interest to the group, and how you handle the sequestration potential. This is really, really important. And so I think, just to build on what Erin said, though, Architecture 2030 has been supporting a variety of different initiatives. And mostly our focus over the last 6 months has been, or actually the last year, has been on the exterior built environment, because of its magnitude of impact that will happen globally. As we talk about doubling the building stock, it's more like we're going to triple the infrastructure, or build out 3 times what we have right now. So it's actually quadruple if you look at it that way. 75% of the infrastructure for 2050 is yet to be built. It's a huge issue. It's a different issue than this issue. But this sleeping giant, it is sobering. And so I think this group is so critical in understanding this issue and then inputting it into a shared framework that the coalition, the ECHO project, has been working towards. Hopefully will become a way that it can standardize this, work with big S standards like ASHRAE 240p and others to get this information out there for the public to really consider, so that we're not blind to a really significant impact.
I'll just add, this is Andrew from the CLF. I'll just add to what Vincent said, that at the ASHRAE Building Decarbonization Conference in October, there will be a panel about the ECHO project, including a number of folks who are on this call as well. And that'll be a really it'll be a great time to introduce the project more broadly to the audience of MEP engineers and ASHRAE members. So I'm really happy that ASHRAE's hosting us for that.
Oh, that's great to know. Thanks, Andrew. Just a couple more questions for our panelists, then we'll move over to our working group updates. I wanna first ask, and I'll start with Stacy. The question is, this came from the chat: how do we get whole building life cycle analyses into our standard practice quickly? And I think we've been asking this question for a very long time, so the word quickly seems a little rhetorical at this point, but what's the best way to push this in the standard practice?
I mean, I think this is what, at the core of our mission is to try to make this as easy and accessible as possible, whether it's whole building life cycle assessment or embodied carbon procurement specs. I think the thing that is largely the answer when it comes to CLF and probably us is education, and Andrew's here too. But we actually do have tools that enable this now. We're working diligently over the next year to make Tally LCA free and replace the data set to make it more robust, which we hope will help to remove the barrier of cost. But I think largely it's how do we get more AE and even C professionals literate with whole building life cycle assessment, literate with the tools. How do we build it into the education that we all get when we're in school? I think a lot of us have learned by doing, but if we would have learned as part of our education process, it's just a whole much bigger, piece of the pie. So education, we need to all be out there teaching this stuff and making sure that people understand how to use it and how important it is. And I know CLF's working on this too.
Yeah, and Jessica, I was wondering if you wanted to add to that as well, because ILFI does promote you doing whole building LCA. So you have anything to add?
Yeah, definitely. So as you mentioned, we do require this, and we require offsetting from this as well, and body carbon reductions in our standards. And what we're looking at moving forward is how can we increase the scope, whether that's in the full requirement for certification or just, like I mentioned earlier, our interest in just putting the data out there, pushing teams to find the data, pushing teams to report it, but maybe not being beholden to the hard, where it might be like softer data or less certain data. So that's definitely something that we're looking at. And echoing also what Stacy said around education, we have an entire education platform that we're revamping and working in a lot of elements, both in the education platform and within our upcoming standard updates, to where even if it's a leading edge issue that we want to work into the standards, maybe having it as an innovation compliance pathway with some education around it, some resource links, pointing out who's doing this work to sort of get it out there as far as getting everyone on the same page, where to start, because that's one of the big questions still, is like, where do project teams start, especially across different scales of projects that we have coming in. Like for a single family home to be doing a whole building LCA and all the things that we require is a big step. So yeah, that's definitely something that we are building in and working towards.
Excellent.
This is Kent. I'll offer up a little bit. Advocacy is a very important aspect in this, because we're starting, even in California last year, that we signed into a law, something that requires whole building LCA on any projects over 10,000 square feet starting in July of 2025. And what the law doesn't do is it doesn't say what that really means. And as we all know, whole building LCA does not equal whole building LCA from one project to another. I mean, whether it included modules A1 to A3 is all they're thinking about, or what disciplines does it include? Does it only include, the structures? So we as an industry need to do, and ASHRAE needs to do this too, but we need to help educate some of the lawmakers, and things like 240p can help with that when it comes out, on trying, what is the scope and what does it mean? And if we're going to start to implement these, we need to be involved in getting these regulations in place so they mean something. And we simply aren't out there only addressing, concrete, steel, and windows when it comes to whole building LCA, and it's A1 to A3. So we really need to go farther. And I think there's a lot of organizations out there that can help on doing this, but we need to do our part on the advocacy side to educate others.
Yes, great. Thank you so much. And I'll do there was the word contractor mentioned early, and it's only been mentioned once so far, but I think I want to reiterate how important it is to also educate our contractors from, school on how to do this work too. Because as a group that, the firm I'm with, we do whole building LCAs. We rely so heavily on some of the information that the contractors provide. And if that information is not correct, we have, there's methods to get there, right? But it's not as whole and complete of a story as if the contractors can really be a great partner to us. So maybe advocating for contractors to also be great partners, or even greater partners than they already are. Okay, so with the last 2 minutes of our
Christy,
panel,
could I make one addition of something that needs,
Yes,
I think
please.
is important?
yes, please.
You know, there's always that Deming, Curtis quote, you can't manage what you don't measure. And the questions that we've been talking about is what are we actually measuring? And then how do we talk about it? But part of that is building awareness, an awareness campaign. So it's slightly different than advocacy and it's slightly different than education. But awareness is not just to our industry, but more broadly to pay attention to this, as Ken mentioned, to Paula Vesta policymakers or not. I think what we're running into, though, is a bit of a fear of talking about this and making it as significant as it really is. If the fear is, and I was chatting with my colleague Erin on this in the chat, is that if we say there's a problem here with refrigerants and heat pumps, that people are going to go back to fossil fuels. And some folks are going to use this as a way to roll this back instead of moving forward. And we can look at any technology that we've had issues with that is part of the renewable revolution, whether that's lithium ion batteries and electric vehicles, and we run into these same kind of issues. We're replacing one problem with another problem. But we shouldn't be fearful about addressing it head on and saying that we're going to work towards finding solutions for this on a public communication sphere, because otherwise we'll be burying it. We won't be looking at it warts and all. So the renewable revolution is happening with or without this solution fixed. And so the question is, do we go backwards by continuing to emit with these refrigerants? Do we fix that solution, or do we go back to inefficient electric systems to use all this renewables? But the grid is going to change. I mean, it's already projecting massive amounts of change, and fossil fuels the fossil age and era will end. So I think we have to be honest about the conversations in public, and what's been really exciting about this group is you have been talking about it, but that needs to permeate into the broader culture. So I'll offer an opportunity in our carbon positive column in Architect Magazine. If we want to talk about this issue, happy to work with anybody who's on the comm side of MEP2040 to bring it to light, warts and all.
Yes, please. We'll definitely take you up on that. And I put in the chat again a link to the MEP2040 website. If you haven't been on it lately, we're doing our level best to continue to post resources there. A couple of the resources that we've published are on our template letters to use to send to vendors and manufacturers, and to that point, raise awareness and get these things in front of the folks who are making this stuff and actually deciding when to incorporate low GWP refrigerants in their products to happen sooner. And I think if we all embark on that awareness campaign, then we can actually move the needle to make that happen. So thank you, Vince. Really good points. Christy, back to you.
Yep, thank you. And that's an excellent segue into our working group updates, because the communications team is one of those updates. So let's go ahead and move over to that. I'll share my screen again. And the first working group is the Data Analytics and Reporting Working Group. If a member could provide their update here.
Sure, that's me.
Thanks, Greg.
So we've been working on a few different things, kind of staying in line with sort of some of the topics we've been working on since we started with this. And one of those is we finally published our refrigerant focused manufacturer outreach letter. It was published, it's on the MEP2040 website, Building Green, as you can see on the right, did a post about it, really just, again, trying to put the word out there and advocating for a quicker transition to these lower and ultra low GWP refrigerants. And, something that's been mentioned several times today is sort of about the refrigerant leakage and how big a piece that is, and really the uncertainty around those leakage rates and the lack of good data there. So we created a template letter for requesting refrigerant leakage data, which we can share the link for that. But essentially, members of our group have been making sort of direct asks with their personal contacts, because we felt like that was probably the best way, because the big sort of like mass asks weren't getting to the right people. So we're working on, asking for the data from large clients with portfolios that are tracking sort of refrigerant loss and replacement, so that hopefully we can put together something that has more defensible data that we can all, really feel like we're, putting a good estimate for that over the life of a piece of equipment. There's also a marketing graphic that he was working on that is in review now. So that's something that's coming in the future, sort of based on an anecdotal incident that we're seeing from some of those studies, sort of so people can equate how big a piece of the pie the refrigerant emissions are. It's looking at basically a 110-pound loss of 410A, and that how many times that equates to driving your car around the equator, which is a lot. And then also some looking at the impacts of load oversizing on MEP embodied carbon. That's something we've talked about a lot. And basically that, if we're not good with our calcs, and that results in larger equipment, that equipment likely is going to have much larger embodied carbon. And so really just trying to get all around that. So yeah, continuing on, pushing this forward, and, hopefully we have some more good information to share in the future.
Thank you. Next up is communications and resources.
So I'm going to tackle this initially, but I will drag Andrew in. And thank you to everyone so far for the support in this particular forum with regard to the communications on this. This continues to be one of our primary focuses, obviously, with regard to communication. These quarterly forums are just fantastic. Once again, this has been absolutely fantastic in terms of how we sort of invite the dialogue with industry experts, invite the dialogue with our signatories out there, continue to sort of grow the movement. As a reminder, we do have our LinkedIn MEP2040 challenge that has been added some time ago. We would encourage all of our signatories and supporters to, when we are posting, make sure you're following us first, but when we're posting, if you could repost that information that's being shared. The website continues to go through ongoing development. That is sort of continuing, and we, as a group, continue to seek additional support from our signatories for communication specialists that you might be able to provide to our working group so that we can continue to grow what we are doing. There are a number of us within the steering committee and within the signatories. We're certainly leveraging our social networks. The Building Green folks have provided on their website a really strong article shouting us out for the urge of collective action, specifically on refrigerants. So that is something that we want to continue to sort of promote in terms of partnerships with other like-minded organizations. And then Vincent mentioned the ECHO project, and I think Andrew is participating, I believe, in that panel. On our behalf. There will be a number of us that will be attending and in place for this ASHRAE decarbonization conferences coming up in October, with Andrew fairly prominently displayed for us on that panel. Andrew, did I miss anything?
Just one thing I'd like to add. One of the people on this call is Christoph Irwin. And Christoph is the host of a really, truly amazing and wonderful podcast that I'd like to have. Christoph, would you please give us a free advertisement for the podcast? Tell us what it is and tell us something about the focus of the podcast on MEP.
Oh my goodness. Echoing what was said earlier.
Your voice is breaking up a lot, Christoph.
How's this?
That's better. Go ahead.
Okay. So yeah, as you said, someone just said advocacy and education is where it's at. We need to flow the right information to the right human minds as soon as possible to make so many of these good ideas happen. So that's the podcast. It's the slow food of this realm. We simply talk until it's all worked out. There's so many of you, Luke, Kent, you know, actually I almost start listing names. There's so many of you. I'd love to get these stories out. It's been stunning how many people change their careers, quit their job, you know, just are blown away with what they hear on the podcast. And like, for instance, just now we work with a client who had never heard that there were health issues with spray foam. And it's like, wow, that's been around for 20 years. So yeah, thanks for the opportunity to do it. And you know, I'm happy to be on the communications group. It's been like Rob, me, and Andrew. I'd love to get more of you involved. It's very important, and please join us. And Andrew, I guess I'm going to ask you again. Let's get some more people on the podcast. You were very generous with your time. It's easy, y'all. We just think of 2 or 3 topics and then we have a conversation. There's, you know, these slides would be, you know, many times over what we would need to have this. So let's do it. Thank you, Andrew.
2 quick questions, Christoph. What is the name of the podcast? And could you put a link to the podcast in the chat window?
It's called the Building Science Podcast. And, but it's really like Building Science 2.0, right? It's not just energy and durability. It's everything. It's electrification, it's health, social justice, and anything in any of the sciences, life sciences, social sciences, physical sciences, as they apply to buildings. In fact, I think social science applied to the built world is really where it's at, right? We have the solutions. It's like we're hungry, but society doesn't know that hunger means, you know, need to go get food. That's our problem right now.
Great.
Fantastic.
Thank you so much, Christoph. And I just want to emphasize that one of the points on Rob's slide there about submitting company plans. So it kind of feels to me like up until now, the history of MEP 2040 has been getting the word out, providing some really excellent education and discussion of embodied carbon and MEP systems through the quarterly forums and so on. We've been building an increasingly large audience through the newsletters, through the meeting announcements, and through the LinkedIn page posts that we do. So all of that is great, but now is beginning to be the time. Now is the time, I'd say, for people for signatories to actually respond to the call and the commitment that companies made when they signed up to first of all submit the plans that you have, and then help us out with case studies and ongoing education, not just about what's happening in the world broadly but about what your company is doing precisely. That would be so helpful and encouraging and inspiring to others. So there's go to the MEP2040.org website and find the submit your plan link on the menu and help us out. Thanks a lot.
I think just a quick follow-up to that, Andrew, is that we recognize not everybody's plan is going to be the same level of detail, et cetera, but it's so important to make sure that you're starting and moving in the right direction. So please, anything that you do have, please submit, right? That is one of the 4 pillars that we have with regard to the MEP 2040 commitment. And we do want to make sure that everybody's sort of moving forward on that. The other thing that I would add is that in terms of the going forward into, you know, the end of this year and then into next year, if there are suggestions from the signatories and supporters and those of you who are attending on topics for future forums, we would love to hear it.
Thanks, Rob. That's actually an excellent segue. We're not quite there yet, but that's going to be the ask at the end of this forum, is everybody drop their ideas for the forum, next forum topics in the chat. So you can get a head start on that if you want. One last working group to update is manufacturers and EPDs. Adam, are you on?
Yep, I'm here. I'll go
All right.
quickly. I know we're short on time. So the main goal of our working group is to make sure the voice of the manufacturer is heard in all this discussion, because our manufacturers are key partners in getting our data, and so we want that communication and input to be smooth. So we had the Q1 forum of this year, which is available on MEP 2040, which had some of their voice in that discussion. So that's available for folks to listen to. We also have some spec language templates and other things that we've published. Our next go forward task is going to be to put together a cohort of key manufacturers, probably a small group, for some development and prioritization of data. So we got some ideas floating around about how we might be able to do that, also in conjunction with some other groups that are involved with development of all this data as well. So we'll have more details on that. If you're a manufacturer that's on here today and you have interest in being a part of this cohort, please reach out to us and let us know, and we'll include you in those communications going forward.
Great. Thank you so much. All right. So we're going to wrap up here, as I've alluded to a few times here. I feel like we've addressed a lot of topics around the singular emission focus of each scope. And then we've also taken it with this forum to the holistic look at a building and its emissions, and begin to ask questions around how they interact with each other. So we need ideas on the next forum topic and into 2024. So if you could take a minute and drop what you want to hear about next in the chat. We're going to use all these ideas to come up with the next forum topics as we go forward. Let's see. And sorry, 1 second. There we go. And that's it for us. We finished 6 minutes early. I feel like that's an accomplishment in itself, but I just want to say thank you so much. Everybody here played a part in this forum and in educating everybody, from the case study presenters that you all had fantastic case studies that really helped shine light on things that we need to be looking at. Our panelists, we brought great perspective to the questions that were presented. And then everybody else, the attendees, we could not do this without all of your great conversation in the chat and your questions. And I can't wait to go back and read through the chat, because I didn't have a chance to keep up, but there's just fantastic conversation going on in there. So as we move forward into the next forum, tell us how we can keep this conversation going and keep progress going toward the goal that we're all trying to strive for. Until then, have a fantastic rest of your week, and thank you so much for joining us.